In 1918, the Nobel Prize Committee made an announcement that sent shockwaves through the scientific community. The honor for chemistry, usually a cause for celebration, was instead shrouded in controversy. The winner was a German scientist named Fritz Haber. He had solved one of the greatest threats humanity had ever faced, yet his award was met with protest. Two fellow Nobel laureates rejected their own prizes, and newspapers filled their columns with scathing critiques. Fritz Haber is, without a doubt, one of the most impactful and tragic scientists in all of history. He literally reshaped our world, but his legacy is stained crimson. The crisis he solved was born from something we take for granted, something absolutely essential for life: nitrogen. Without it, life simply stops. Plants can't grow, their leaves turn a sickly yellow, crop yields plummet, and civilizations starve. By the mid-1800s, the world was hooked on a strange and finite resource for its nitrogen. It was a brittle crust of fossilized bird droppings, called guano, found on a few remote islands off the coast of Peru. These cliffs of ancient poop, some towering 100 feet high, were so precious they sparked wars. Spain even went to war with its former colonies just to control these guano-covered rocks. The price was astronomical. People were trading 4 pounds of guano for 1 pound of pure gold. But by 1872, the guano was running out. The world was facing what one chemist called deadly peril. In 1898, Sir William Crookes, a leading scientist of the time, made a terrifying prediction. He declared that within 30 years, mass starvation on a global scale was inevitable, unless, as he put it, the chemist comes to the rescue. The irony was that nitrogen makes up 78% of the air we breathe. It's all around us. But it's locked away by one of the strongest bonds in nature, a triple bond so tough it requires a massive 9.8 electron volts of energy to break. For a century, the greatest minds in chemistry had tried to crack it, and every single one had failed. And then came Fritz Haber. At 36, he was a relatively unknown, low-level academic at a small German university. But he was driven by fierce pride and an intense competitive spirit. He decided to tackle the impossible problem. His idea was to combine nitrogen from the air with hydrogen, but not just under immense pressure. He would also use scorching heat and, most importantly, a secret catalyst. His obsessive search for the perfect catalyst led him to an unlikely place, a light bulb factory. He started moonlighting there, which gave him access to one of the rarest materials on Earth at the time, osmium. He managed to get a small sample and brought it back to his lab. Then, in the third week of March 1909, the moment of truth arrived. Inside his custom-built apparatus, Haber subjected the nitrogen and hydrogen to an agonizing 200 atmospheres of pressure and a blistering 500 degrees Celsius heat, all in the presence of his precious osmium catalyst. And finally, the unbreakable triple bonds of nitrogen yielded. As the resulting gas was cooled, a single pale milliliter of liquid ammonia dripped slowly into a beaker. Haber was ecstatic. He sprinted through the halls of the institute, shouting to his colleagues, "Come on down! There's ammonia!" He had done it. He had made bread from the air. This single drop of liquid unleashed a flood. The German chemical giant BASF quickly commercialized the Haber process, building a massive factory that churned out 5 tons of synthetic ammonia every single day. The world rejoiced. Farmers could now grow 4 times as much food on the exact same plot of land. This single invention allowed the global population to explode, quadrupling from under 2 billion to the 8 billion we see today. In fact, right now, as you listen to this, approximately half of all the nitrogen atoms inside your own body came from the Haber process. Fritz Haber became fabulously wealthy, a celebrated national hero, and a friend to scientific giants like Albert Einstein. But like all great discoveries, this knowledge was a double-edged sword. In 1914, World War I ignited across Europe. Haber, a fervent and sometimes fanatical patriot, immediately volunteered his expertise to the German war effort. The German army had a critical problem. They were running out of explosives, which relied on nitrates imported from overseas, a supply line now cut off by a British naval blockade. But Haber had the solution. His revolutionary fertilizer, ammonium nitrate, was also a devastatingly powerful explosive, as the world was tragically reminded in Beirut in 2020. Haber successfully lobbied the German High Command to convert his ammonia factories from making life-giving fertilizer to making instruments of death. He went from making bread out of the air to making bombs out of the air. But Haber believed chemistry could do even more to serve his country. He took his prestigious institute, the very symbol of humanity's salvation from starvation, and converted it into a chemical weapons laboratory. When a colleague voiced discomfort with this dark turn, Haber rationalized his work, arguing that a swift, decisive weapon would end the war more quickly and ultimately save countless lives. At 6 p.m. on April 22, 1915, his chilling experiment began. On the battlefields of Ypres, with the wind blowing toward the Allied lines, German troops opened the valves on 5,000 gas cylinders, unleashing 168 tons of chlorine gas. A greenish-yellow wall of vapor, 2.5 times heavier than air, rolled slowly across no man's land. It sank, inescapable, into the Allied trenches. Any soldier who inhaled it suffered a horrific, agonizing death. The chlorine reacted with the water in their lungs, creating hydrochloric acid, causing them to literally drown on dry land. More than 5,000 soldiers died in that single, terrible attack. For this, Fritz Haber was promoted to the rank of captain. By 1917, his institute had become a mini Manhattan project for chemical warfare, employing 1,500 people and developing ever more lethal agents like phosgene and mustard gas. His work was directly responsible for an estimated 100,000 deaths during the war. When Germany finally surrendered in 1918, Haber's world collapsed. He was branded a war criminal by the Allies. His immense personal wealth was wiped out by Germany's hyperinflation. In a desperate, almost alchemical quest, he spent years trying to extract gold from seawater to pay Germany's war reparations, a project that ultimately failed. But the final, most terrifying chapter of his legacy was yet to be written. In 1933, the Nazis rose to power in Germany. Haber, who was Jewish by birth, but had converted to Christianity and saw himself as a German first, was forced to resign from his post. He had a military exemption, but he quit in solidarity with the Jewish scientists being purged from his institute. He fled Germany, a broken man, and died just a year later in a hotel room in Switzerland. However, immediately after World War I, Haber's institute had developed a powerful cyanide-based insecticide to help with fumigation. They called it ZyklonB. A decade after the man who saved billions from starvation died, the Nazis requested a small but sinister modification to this chemical. They asked that the foul-smelling warning agent, added to prevent accidental poisoning, be removed. The resulting odorless invisible form of ZyklonB, a direct descendant of the research done at Haber's own institute, was used to perpetrate the Holocaust, murdering millions in the gas chambers of Auschwitz and other death camps, including some of Haber's own relatives. Fritz Haber's story is a profound and disturbing tragedy. It forces us to confront the terrifying duality of knowledge. Ammonium nitrate is both a fertilizer that feeds the world and an explosive that shatters it. The very same chemistry that enabled our population to flourish is the same chemistry that was twisted to destroy millions. Haber's life leaves us with an urgent, unanswered question. How do we continue to expand the horizons of human knowledge without destroying ourselves in the process? Thank you so much for watching. If you found this story as compelling as we did, please consider liking this video and subscribing to the channel for more deep dives into the stories that shaped our world. We'll see you in the next one.